Dear all, a grand welcome to Outens Edu's online session. In this session, we are going to discuss the basic concept of probability theory. We often say or hear the phrases such as, probably it will be rain today. We are not sure about whether it is rain or not, but we are expressing a chance for rain. Similarly, we may say, Shambhu will stand first in the examination. In this case also, we are not sure whether Shambhu will be first. But we are expressing a chance for Shambhu to be the first in the examination. Similarly, we may say, most probably India will win this match against South Africa. Here also, we are expressing a chance for winning, but we are not sure whether win or loss. So there is a prediction. So there is a chance or a probability. This probability theory had its origin from gambling or game of chance. Famous mathematicians such as Leibniz, Pascal, James Bernoulli, Fermat had done great work in the theory of probability. Suppose we are making some prediction. So as to increase the accuracy of prediction, we should have some good knowledge in the theory of probability. In this session, we are discussing the basic concept of probability. Suppose I have a coin. Now I am doing, that is tossing the coin, or the outcome or the result may be either head or tail. Here it's come tail. Okay. Then, if I am doing or I am performing this experiment any number of time, in all the cases, the outcome will be only either head or tail. That is, we know the outcome or we know the results in advance. But for a specific experiment or for a specific toss, the exact outcome will be known only after performing the toss or only after performing the experiment. Such an experiment is called random experiment. So we define one term in probability theory. That is a random experiment. So first, the term is a random experiment. So random experiment is an experiment which can perform any number of times, but all cases the outcome or the result will be known in advance. In this case, I can perform any number of times this experiment, that is tossing the coin. But the experiment's results is always either head or tail. But what is the exact result? Exact result should be known only after performing the experiment. Okay, so random experiment is an experiment which can be performed any number of times, whose outcome will be known in advance, but the exact results of the experiment will be known only after performing the experiment. So, my outcome is either head or tail, right? So, I can represent this in a set, that is set having 2 points. One point is head and second point is tail, or two elements, head and tail. This set is called sample space. So, we define the second term in probability theory, that is sample space. Sample space. So what is our sample space? Sample space is a set in which each element or each point will represent an outcome of the experiment. And after completing the experiment, the outcome or result will be exactly a single point in this sample space. So, for tossing this coin, either head or tail. So, these are the points or elements in sample space, either head or tail. So, we have 2 points or 2 elements in the sample space. But after performing this experiment, the result should be exactly 1 point in the sample space. Here I got tail. So, this is the exact results. That will be known only after performing the experiment. So, we define 2 terms in probability, that is very important terms, that is First is random experiment and second is sample space. Random experiment means any experiment which can be performed any number of times whose outcome is always known. But the exact outcome will be known only after performing the experiment. And the outcome of this random experiment can be represented by a set. And each point will represent an outcome. And after completing the experiment, the outcome will be exactly a single point in the sample space S. So we have a random experiment R and a sample space S. Okay. Consider another example. An example in which I am tossing this coin twice. First tossing. So the result may be either head or tail. So I am representing this by an tree diagram. So this is our coin, my coin. I am tossing the coin. So the outcome will be either head or tail. Now I am performing this experiment twice. So if I got a head, then also I will toss the coin again. So again the output will be either head or tail. Right. Here it is tail. So I am performing the experiment, that is tossing the coin again. Again I will get either head or tail. I am not sure whether I will get head or tail. So what are the sample spaces for this experiment? This can be represented by a head and a head, two heads. Okay, now this is head and a tail. So head, tail. This is tail, head, tail, head. This is tail, tail. So how many outcomes? So we have total 4 possible outcomes in the sample space that can be represented by S is equal to, first outcome is H, H, both are heads. Second is one head, first is head and second is tail. Third outcome is tail and head. And the fourth outcome is both are tails. So this is our sample space. And sample space have 4 points. 1, 2, 3, 4. So total number of possible outcomes are 4. Okay. Suppose, what is the chance of getting 2 tails in this experiment? So I am looking the sample space. What are the favorable outcome? Favorable outcome is we want 2 tails. So here 2 head, 1 head, 1 head, 1 tail, 1 head. So these 3 are not favoring for 2 tails. The favorable outcome is this. That is, in this case, both are tails. So this is a favorable outcome. Okay, favorable outcome. Now, what is the chance of getting 2 tails while performing this experiment? That is the probability for getting 2 tails. So that P, that is the probability of getting 2 tails. That is equal to number of favorable outcome divided by total number of possible outcomes. That means number of favorable outcome divided by total number of possible outcomes. That is total number of possible outcomes. Okay, what's the number of favorable outcomes in this case? We have only one favorable outcome. So the numerator becomes 1. What's the total number of possible outcomes? That is 1, 2, 3, 4. So 1 by 4. So this is the probability of getting 2 tiles while tossing a coin twice. This is equal to 0.25. Okay. In the probability theory, the probability of an event, of any experiment will less than 1. So the probability will always less than 0 less than p less than 1. 0 means the event will never happen. 1 means the event will surely happen. So the probability for chance for occurring an event will lies between 0 and 1. So that is 0 less than p less than 1 means 0. If the probability is 0 means that event will never happen. Probability is equal to 1 means that event is always happen. In between 0 and 1 means that percentage for the chance for occurring. Here probability is equal to 0.25. So the occurrence of this event, that is two tails or coming of two tails in the toss, is 0.25. That is equal to 25%. The occurrence of this event is 25%. But probability will never become negative. It is always a positive value in between 0 and 1. Okay. Now, suppose I want. What is the probability of getting one head and one tail? Now I am looking to the sample space. What are the favorable outcomes? Favorable outcome means outcome favoring one head and one tail. This is two heads, that is not favoring. One head and one tail, that is favoring. One tail and one head, that is also favoring. So number of favorable outcome is 2. So probability for getting one head and one tail, that is equal to number of favorable outcome. Here that is 1 and 1. So 2 favorable outcome. What are the total number of possible outcomes? That is 4. So 2 divided by 4, that is equal to 1 by 2 is equal to 0.5. 0.5 means 50%. So we have 50% chance for getting one head and one tail. Okay. Now what is the probability of getting two heads? That is number of favorable outcome is 1. That is H and H. That is only favorable outcome. So probability of getting two heads is equal to number of favorable outcome. Number of favorable outcome is only 1. That is 1 divided by possible outcome, that is 4. 1 by 4, that is equal to 0.25 is equal to 25%. So the value of probability lies between 0 and 1. Probability is equal to 0 means that event will never happen. And probability is 1 is equal to 100% that event will happen. But probability will never be negative. That is a positive value lies between 0 and 1. Now consider another example. We all heard about dice. A cubic die. A cubic die has 6 faces marked as 1, 2, 3, 4, 5, 6. Okay, so we have 6 faces for a cubic die. Suppose I am drawing a cubic die. So what is the probability of getting a 1? So we have for a cubic die, the sample space be any of the 6 numbers, that is either 1, 2, 3, 4, 5, 6. So we have 6 possible outcomes. So by a fine die we are throwing, so for getting a probability of getting any number in between 1 and 6 is 1 divided by 6. That is probability of getting either 1 or 2 or 3 or 4 or 5 or 6 is equal to number of favorable outcome, that is only 1, divided by total number of possible outcome, that is 6. So the probability of getting a 1, either of this number is 1 by 6. Suppose I am tossing a fair die twice. Then what are the sample spaces? Let us draw. I have a die. This is our die. I am tossing the die. So I will get either 1, either 2, either 3, 4, 5 and 6. So output will be any of this number. Now again I am throwing the die again. So the die is thrown twice. So what may be the outcome? This may be again 1. So we have 1, 1. Or this may be 2. So we have 1, 2. Maybe 3. So outcome is 1 and 3. Similarly, maybe 4. So outcome be 1 or 4. The second chance, it may be 5. So 1 and 5. Maybe 6. That is 1 and 6. Now, suppose first toss or first throw 2 came. Then the second throw either 1, 2, 3 or 5 or 6 will came. Okay. So, this is 1, 2, 3, 4, 5, 6. So we have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 or 2, 6. This continues. What about 3? Again we have 6 possible outcomes. Right. This is 1, 2, 3, 4, 5, 6. Right. So 3, 1 or 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Right. Now here also 6 chance. 1, 2, 3, 4, 5 and 6. So the outcome is 4, 1, 4, 2, 4, 3, 4, 4, 4, 5 and 4, 6. Here also 6 branches. That is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is either 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 or 5, 6. Right. Now the first chance 6. Here also we have 6 possible outcomes. Okay. This 1, 2, 3, 4, 5, 6. Here 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So how many possible outcomes? We have 6 plus 6, 12, 18, 24, 36, 30 and 36. So total number of possible outcomes are 36. So our sample space S is equal to 1, 1, 1, 2, 1, 3. This going on. Then the last become 6, 4, 6, 5 and 6, 6. So the sample space S have total 36 elements or 36 points. What is the probability of getting 6 in both cases? So what is the probability of this 6, 6 for getting 6, 6? That is for both row the output will be 6. That means how many possible outcomes? Possible outcomes are 36. And how many favorable outcome? Favorable outcome is only 1. So the probability for this occurrence is favorable outcome, that is 1 divided by number of possible outcome, that is 36. Now what is the probability of getting an even number in both row? That means even number means either 2, 4 or 6. This will be coming in both the cases. So here 1. So that is an odd number. 1 is an odd number. For here this is a chance. This is a chance. This is a chance. So 3 chances or 3 possible outcomes. Here one number is always odd. So we can neglect. Here 4, 2, 4, 4, 4, 6. 3 possible or 3 favorable outcomes. Here one number is always odd. So we neglect. Now take this. Here this is possible. 6, 4 is possible. 6, 6 is possible. So number of favorable outcome is 3 plus 3 plus 3. That is equal to 9. So the probability of getting even numbers in both cases is equal to number of favorable outcome, that is 9 divided by number of possible outcome, that is 36. So probability is equal to 1 divided by 4. 1 by 4 is equal to 0.25, that is 25%. So there's a probability of 25% for getting an even number in both rows. Now, what is the probability of getting an odd numbers in both rows? So odd numbers in both rows means 1 1, this is okay, 1 3, okay, 1 5. We have 3 chances, right? That is 1 1, 1 3, 1. Here one number is even, so we can neglect this entire samples. Now here 3 1 okay, 2 3 okay, 3 5 okay, and the rest is one number is even, so we neglect. Here one number is always even, so neglect. Here 5 1 okay, 5 3 okay, 5 5 okay. Here one number is always even, so neglect that case. So probability of getting odd numbers in both rows, that is equal to number of favorable outcome, that is 9, divided by total number of possible outcome, that is 36, that is equal to 1 by 4, that is equal to 0.25, that is equal to 25%. So the probability of getting even number in both cases and odd number in both cases are 25%. Discuss another experiment. The experiment is we are tossing a coin and a die. Okay, I will explain the experiment. I have a coin. I am tossing this coin. So the output will be either head or tail. This is my coin. Now I again toss the coin. That means the coin is tossed twice. So the outcome will be either head or tail. Here also either head or tail. Now I have a die. The condition is that if the second outcome is head, then I will throw the die. If the second outcome is a tail, then I will toss the coin. So that is a condition. Now look at. First I toss, I get a head. Then I toss. I will get either a head or a tail. So head. So as per the condition, then I will throw a die. So the outcome of a die will be either 1, 2, 3, 4, 5 or 6. So this will be 1 or 2 or 3 or 4 or 5 or 6. So what is the outcome here? So we had head, head 1, head, head 1. Here head, head 2. Similarly, this is head, head 3. Then head, head 4. This is head, head 5. Head, head 6. So I have what 6 points in the sample space. Now suppose the second toss results in a tail, then I will toss a coin. That means the result may be either head or tail. So this will represent the point head, tail, head, head, tail, head. This will represent head, tail, tail, head, tail, tail. Now here I got tail, then head. So second toss is a head. So throw a die. The outcome be 1, 2, 3, 4, 5 or 6. Okay. So this can be represented by TH1, TH1, TH2, TH2, TH3, TH4, TH5 and TH6. Okay. Now here a tail. So I toss a coin, that is either head or tail. So tail, tail, head, that is TTH. Here tail, 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 triple T. Okay. So what are the possible outcomes? A number of possible outcomes. 6 plus 2, 8. 8 plus 6, 14. 14 plus 2, 16. Total number of possible outcomes. Sample space is equal to 16, all these elements. So total is equal to 16 points. Okay, this is our sample space. Now, I want to find the chance or the probability of getting all tails. That is, all the experiment will result in T. That is, what is the probability of getting 3T? That is, probability of getting 3T. That is, all the cases the output will be tail. That is equal to number of, what is the number of favorable outcome? Only 1. So that is equal to 1. How many possible outcomes? That is 16. So probability is 1 by 16. Okay. What is the probability of getting exact 2 tails? That is probability of getting exact 2 tails. So tails to be exactly 2, right? That is exact, not at least, exact 2 tails. Now look at the probability. Here it is 2 tail, 1. Then there is no chance here. Here there is 1 chance for 2 tail. So that is equal to number of favorable outcome 2 by total possible outcome 16. So that is equal to 1 divided by 8. Okay. Now what is the probability of getting at least 1T? At least 1T. At least 1T means 1T, 2T or 3T. That means the probability of getting at least 1 tail. At least 1 tail means it may be 1 tail or 2 tail or 3 tail. So at least 1 tail means tails may be 1, 2 or 3. So look at the favorable outcome. Here there is no T. Here there is 1T. So 1. Here 2T. This is favorable. 1, 2. This is favorable. 3, 4, 5, 6, 7, 8, 9, 10. So 10 favorable outcomes. So that means 10 divided by 16, that is equal to 5 by 8. So in this manner we can define or we can do more problems in this problem itself. Do more problems in this section. There are problems like, suppose we have a bag. In that bag there are some oranges and mango and apple. Then how many ways we can select apple, mango and orange? Then there are interesting problems from group of students. Suppose we have some boys and girls in a class of students in a class. Then we want to select some particular persons. Then what is the method for selecting it? Then there is problem of cards, playing cards. Playing cards problem. Playing cards problem. A lot of problems coming from playing cards. So these things we will discuss in the next session. So thank you for watching. If you are not subscribed, please subscribe.